As I highlighted before, Google Cloud Storage is not your only choice when it comes to storing data in a data lake on Google Cloud. You don't want to use cloud storage for transactional workloads. Even though the latency of cloud storage is low, it's not low enough to support high frequency writes. For transactional workloads, use Cloud SQL or Firestore, depending upon whether or not you want SQL or NoSQL. You don't want to use cloud storage for analytics on structured data. If you do that, you'll spend a significant amount of compute parsing the data. It's better to use Cloud Bigtable or BigQuery for analytic workloads on structured data, depending upon your latency required. So we keep talking about transactional versus analytical workloads. What exactly do we mean here? Transactional workloads are those ones that require fast inserts and updates of records. You want to maintain a snapshot, a current state of the system. The trade-off is that queries tend to be relatively simple and tend to affect only a few records. For example, take a banking system. It'll deposit your salary from your company to your account. That's a transaction. It updates your balance field, hopefully going up. The bank is using an online transaction processing, or OLTP. An analytics workload, on the other hand, tends to read the entire dataset and is often used for planning or decision support. The data might come from a transaction processing system, but it's often consolidated from many different OLTP systems. For example, a bank regulator might require us to provide a report of every customer who transferred more than $10,000 to an overseas account. They might ask the bank to include customers who try to transfer the $10,000 in smaller chunks over a period of a week. A report like this will require significant scanning of that large data set and require a complex query that includes aggregating over moving time windows in SQL. This is an example of an online analytical processing, or an OLAP workload. The reason why we treat these use cases differently is that transactional systems are heavily write-focused. These tend to be operational systems. For example, a retailer's catalog data will require continual updating every time the retailer adds a new item or changes its price. The inventory data will need to be updated every time the retailer sells one of those items. This is because the catalog and the inventory systems have to maintain an up-to-the-moment snapshot of the existing business. Analytical systems, on the other hand, can be periodically populated from the entirety of the operational systems. We could use this once a day to generate a report of all the items in our catalog whose sales are increasing but whose inventory levels are low. Such a report will have to have read in a bunch of data, but is not going to write much. So OLAP systems, or OLAP systems, are read-focused. So recall what we said. Analytical systems can be periodically populated from the operational systems. Data engineers build those pipelines to populate the OLAP or OLAP system from the OLTP, the transactional processing system. One simple way might be to export the database as a file and load it into the data warehouse. And we call that EL, or extract and then load. On Google Cloud, a data warehouse option that's very popular tends to be BigQuery. There is a limit to the size of the data that can be loaded directly into BigQuery. This is because your network might affect that bottleneck. Rather than load the data directly into BigQuery, it can be much more convenient to first stage it and load it into Google Cloud Storage as a data lake, and then load Google Cloud Storage through a pipeline into BigQuery as your data warehouse. This is because Google Cloud Storage supports multi-threaded, resumable loads of data. If you're using GSUtil, you can literally just provide a -m option there. Loading data from cloud storage will also be much faster because of the high throughput it offers. A feature that has recently been released is the ability for BigQuery to query data files that live in Google Cloud Storage, directly query them, without having to first load those files into BigQuery's own native storage. This is called a federated query, or creating an external data source connection. A super popular use case is if you have your data files in a variety of formats like CSV, Avro, newly supported, you can do Parquet or Apache Orc, and then query them directly into BigQuery. So let's see a quick demo of how this looks from GCS to BigQuery using a federated SQL query.